Machine learning, a deep dive. Machine learning, or ML, is a subfield of artificial intelligence. It empowers systems to learn from data without explicit programming. This represents a paradigm shift in how we approach problem-solving with computers. At its core, machine learning analyzes data. It identifies patterns and makes predictions or decisions based on those patterns. The power of ML lies in its ability to learn and improve over time. This capability makes it incredibly useful across a vast array of fields. From healthcare to finance, machine learning is transforming industries. Its adaptability is key to its widespread adoption. The machine learning process begins with training data. The algorithm is fed a large dataset relevant to the task at hand. This data forms the foundation for the model's learning. Next, the algorithm uses this data to build a mathematical representation. This representation, or model, captures the underlying relationships within the data. The model is the core of the machine learning system. Once the model is built, it can be used to make predictions. These predictions are based on new, unseen data. The accuracy of these predictions depends on the quality of the training data and the effectiveness of the algorithm. The model can also be retrained with new data. This adaptability allows the model to improve its accuracy over time. Continuous learning is crucial for dynamic environments and evolving data patterns. There are several types of machine learning. Each type is suited for different types of problems and data. Understanding these types is essential for choosing the right approach. Supervised learning involves training on labeled data. This means the data includes the desired output for each input. Supervised learning is used for tasks like image classification and spam detection. Unsupervised learning deals with unlabeled data. The goal is to discover hidden patterns and structures within the data. Applications include customer segmentation and anomaly detection. Reinforcement learning focuses on training an agent. The agent makes decisions to maximize a reward. This type of learning is used in game playing and robotics. Machine learning has a wide range of applications across various industries. Its ability to automate tasks and make predictions is invaluable. Let's explore some key examples. In healthcare, machine learning aids in disease diagnosis. It also accelerates drug discovery and enables personalized treatment plans. This leads to more effective and efficient healthcare. In finance, machine learning is used for fraud detection. It also powers algorithmic trading and risk assessment. These applications help to improve financial stability and security. E-commerce benefits from machine learning through recommendation systems. Personalized advertising and supply chain optimization are also key applications. This enhances the customer experience and improves efficiency. Machine learning is also present in our everyday lives. Voice assistants, search engines, and social media feeds all rely on ML. These technologies have become integral to modern life. Despite its potential, machine learning faces several challenges. Addressing these challenges is crucial for realizing its full potential. Data quality and interpretability are two major concerns. Data quality is paramount in machine learning. Biased data leads to inaccurate results. Incomplete data also compromises the accuracy of the model. Interpretability is another significant challenge. Understanding complex ML model decisions can be difficult. This lack of transparency raises concerns about accountability. Machine learning has undeniable potential to transform industries. It also has the potential to improve our lives in countless ways. This makes it a crucial area of focus in AI. Thanks for watching Tadhem.